Hello everyone, welcome back to this video series on clinical SAS SDTM programming. In this video, we will see how to create RP dataset, which is Reproductive System Findings dataset, using an example concept wherein we are collecting information about the childbearing potential and menopause status of the female participants in the study. So let us try to understand the concept of RP domain first, and then we will move on to the further discussion. So in some clinical trials, we may have to collect data about the physiological and morphological findings related to the male and female reproductive systems. So some examples data points related to the physiological or morphological findings of reproductive systems are the childbearing potential of the participants, or the menopause status, or the number of pregnancies, or the birth control method that is being employed. And then we have, as per the SDTM standard, so we have a standard domain for capturing these findings related to reproductive systems, and that is our reproductive system findings or RP dataset. So RP dataset belongs to findings class and has an expected structure of one record per finding or result per time point per visit per subject. So what type of information is typically collected or presented in RP domain is the date of assessment, test performed status, whether a specific question is being asked or not. If it is not performed, the reason it is not performed will be collected. And then we will use a abbreviated name for each of the tests of the questions that are being asked. So that would be presented in the short name of the test, which is nothing but our test CD variable, and then name of the test, which is nothing but our RP test variable. And then we'll present the result in original units and standard units wherever applicable after converting the original units to standard units. And then we may present some derived information like baseline flag when the results of the tests are collected over pre and post treatment period. So this is some general understanding of the RP domain. Now let us move to the lesson description on what we will be seeing in this lesson. So in this lesson we will see how to create new rows for separate test CDs from different variables present on a record. And then we will see how to derive study day, how to derive epoch variable using subject elements dataset, and then how to create baseline flag and how to create sequence variable. So let us now move to the CRF and see the form that is being used to collect the information about reproductive and menopause status. So we have this form which will be used to collect the information for the reproductive system findings. So let us quickly go through the question that we have. The first question is assessment performed, and if the assessment is performed, the date when it is performed. And we have two questions primarily. So the first one is the subject of childbearing potential? So for which the responses are no or yes. And then we have this question, what is the status, menopause status of the participant? And then for which the possible responses are pre-menopause or menopause. So let us now see to which SDTM variables this information gets mapped to. So here on the left hand side, if you see the raw variable name, so ideally what will happen is we will get one data set for each of the forms. So here in the form is repmen, so we will have a raw data set named repmen in our library for us to use in our SDTM dataset programming. In this raw dataset, we will have these variable names to capture the information on each of these questions. For example, if the assessment performed information, the result would be stored in a variable named repmen yn, and the date actually performed would be stored in a variable named repmen dat. And then similarly, the response for this question is the subject of childbearing potential would be stored in the variable childpot with the possible values of no or yes. And then the possible values of pre-menopause and post-menopause for this question of menopause status would appear in a variable named menostat. So now let's see to which SDTM variables we need to map each of this information. So we have this question, assessment performed. Let us see the SDTM annotation for it. So here we have the annotation as RP stat is equal to not done when RP test seed is equal to RP all when no. So when assessment is not performed at all, so we are being asked to create a record with RP test CD is equal to RP all. On that record, we are being asked to set the value of not done in RP stat variable. So let us now move to the next variable. So if yes, date performed. So let us see. So the date that this assessment is performed has to be mapped to RPDTC variable in SDTM RP domain. And then we'll see the next question. So here for this is the subject of childbearing potential. So we are being asked to create a record with RP test CD is equal to child POT and store the associated result in the variable RP ORRES. So the information for this question would be present on a row with the value of child potential on RP test CD. And then we'll see the next question. So here for the menopause status, so we are being asked to create a new row with RP test CD is equal to menostat and then store the value of premenopause or menopause in the variable RP ORRES. Let us now move to the specification. So here we have the variable name, variable label, and the type of the variable, some general comment, and the derivation logic for the variables that are coming directly from this rod form repman dataset. So for study ID, we are being asked to set the value of myCSG, and for domain, we are being asked to set the value to RP. And then for uSubj ID, we are being asked to concatenate the value present in project and subject variables with a hyphen in between. And then for RP-seek, we are being asked to sort the records based on subject ID, RPDTC, visit num, visit, RPSPID, and then assign as 1 on the first record of each subject and increment by 1 for each subsequent record of that subject. And then we have our RPSPID for which it says, so populate using repmen.record position if the in 3-digit format padding with leading zeros where applicable. And then we have RP test CD, so which says create one record for each test collected. So as we were seeing, so in raw data set we would get one row with the information for childbearing potential and menopause status as variables, but we'll have to restructure it when creating our SDTM dataset. So we are being asked to create a separate record for each test CD collected. So we are asked to create a test CD called child POT when creating record for child POT variable in our raw dataset, and then populate as menostat when creating the record for menostat test CD. And then we are being asked to create a record with RP all in RP test CD when creating the record when repmen yn is equal to no. So we have seen that when there is no assessment performed, so we were asked to create a record with RP test CD is equal to RP all. So this is what is mentioned here in the specification. And then we have RP test which says populate as childbearing potential when RP test CD is equal to child POT, and then populate as menopause status when RP test CD is equal to menostat, and then populate as reproductive system findings when RP test CD is equal to RP all. And then RP ORRES, so this is kind of already discussed when creating our RP test CD. So we are supposed to create a record for information contained in child POT and a record for the information present in menostat variable. So for RP ORRES, the derivation is saying populate using these two variables. So on the appropriate test CD rows. So as both these information childbearing potential and menopause status do not have any units associated with that, so we are being asked to set the value to null. And then for RPSTRESC, we are being asked to populate it using SDTM RPORRES. So this is equivalent to the value present in RPORRES. And then we have RPSTRESU. So here we are being asked to present it as a copy of RP ORR ESU. So it will be null as RP ORR ESU will be null. And then RP stat, so it says set to not done when repmin dot repmin yn is equal to no. So we have seen that when we were asked to create a record with RP all in RP test CD when repmin yn is equal to no. So on that record we are being asked to set the value of not done in RP stat variable. And then we have RP rees nd. So we are being asked to populate it with the value of not collected when RP stat is equal to not done. And then we have RP BLFL derivation. It says set to y on the latest record with non-missing result on or prior to SDTM DM RFST DTC per each test. So we'll have to identify the records which are on or prior to treatment start date or reference start date, and if there exists more than one record, so we'll have to use the latest record which contains the non-missing result. And then we have visit number variable, so which says populate using folder seek. And for visit, so we are being asked to populate it as folder name, populate using folder name. And we have epoch derivation. It says populate SDT using SDTM SC epoch by comparing RPDTC with SC STDTC and SC ENDTC of each element of the subject, and populate as treatment when the record falls on the boundary of screening and treatment elements. Populate as treatment when the record falls on the boundary of treatment and follow-up. So we'll see how our SE is structured and how we are going to derive this. We'll get a better understanding of this when we look at the programming. And then we have RPDTC. It says populate using repmin.repmin DAT in ISO 8601 format. So we have to use the information present in repmin DAT variable and convert it into ISO 8601 notation. And then we have this study day variable which is RPDY. It says if RPDTC is on or after reference start date, then take the difference between RPDTC and RFSTDTC from DM dataset and add 1 to that difference. Otherwise, if the date is before reference start date, then assign the value to RPDY as the difference between RPDTC and RFSTDTC. So let's now move to the programming. So before we go through the program explanation, we will go through our input dataset first. So we have our demographics dataset in which there are 3 subjects information 1001, 2003 and 3010. And then we have our subject elements dataset. Here we have the start date and end date of each of the elements which the subject has completed. So if we take a look at subject 1001, so this subject has information for 3 elements, so screening, active and follow-up. So and those 3 elements correspond to screening epoch, treatment epoch and follow-up epoch. So we were asked to check our RPDTC and compare it with the start date and end date of each of the elements, and we were asked to populate with the epoch value from that record where our RPDTC is falling in between that epoch start and end dates. So we'll have to cross check our RPDTC between start date and end date of each of these 3 rows, and if it is falling anywhere in between, so we'll have to populate with the associated epoch from that record. So we'll see the programming of this. And then we have our SV dataset, but I don't think we'll be using SV here. And the next input dataset, which is our core dataset, is our repmin dataset. So here we have variables like project, subject, folder seek, folder name, record position, and the core information that is collected on the form, repmin yn, repmin dat, childbearing potential, and menopause status. So we'll be creating a row based on the information present in repmin yn, childbearing potential, and menopause status. So let us now move to the programming explanation as we have seen the structure of the input datasets. So here we are using our repmin dataset and creating a new dataset called RP01. So we are assigning the text myCSG to the study ID variable as specified in the specification. So we use the domain variable to indicate the name of the abbreviation of the domain that we are creating. So RP is the abbreviation for reproductive system findings. So we are assigning that text to the domain variable. And for useID, we were asked to concatenate the value in uh, study ID and subject with a hyphen in between. So we are achieving that using catex function. So the first argument within the catex function would be used to specify the separator when trying to concatenate the values present in the variable specified from second argument. So this will concatenate the value present in study ID and subject but with a hyphen in between. So this will achieve our useID derivation. And then we are creating our RP SPID variable. So for which we were asked to convert the value present in record position to a 3-character wide string, but add leading zeros wherever applicable. So say for example, if a number in RP record position is 1, so we would have to present RP SPID as 001. If record position has a value of 20, say for example, so then we would have to present it as 020. If it is, say for example, 199, so it has to be directly presented as 199. So that can be achieved using this format, SAS format of Z3. So what this does is it checks the total number of characters available, as we are indicating that with Z3 indicates that if the total number of characters is less than 3, pad it with leading zeros. So we are creating RPSPAD using put function on record position using Z3 format. So, and we are doing that only when record position is not is equal to missing. And then here we are creating our RPDTC variable. So we are checking if the raw variable repmand.dat is having a value or not. If it has a value, so let us take a quick look at the possible values in repmand.dat. So the date values are in the format of 15-/Jan/2010. So this format is called as date11 format in SAS. So what we are doing here is, so we are converting this character date value to numeric date value using input function here. So and then the resulting numeric date value is converted back again to a character value using put function, but with yymmdd10 format. So what this does is, so it will translate first this 15 Jan 2010 into number of days from 1st Jan 1960 with this input function, and then that would be converted into a numeric character date value of yymmdd10 format. So we will see how this will look like when we examine the output dataset that is getting created out of it. So this is how we are converting our collected raw date to ISO 8601 notation. And then here comes our core logic of creating rows for each of the test CDs. So here we have created some variables which would be common for all the test CDs, and then we are outputting a record for each of the test CD using output statements here. So we'll now see how we are creating that. So here first we are checking if the value present in repman yn is equal to no. So we are converting the value in repman yn to uppercase and then checking for the uppercase no. So this is the basic example of a defensive coding. So if you are not sure whether the value in repman yn will be uppercase or lowercase or prop case, so it's best practice to convert it into uppercase and then check it with the uppercase value on the right hand side, or you can use lowercase function and then check on the lowercase here as well. And then so if repman yn is equal to no, so we were asked to create a record with rp test cd is equal to rp all and then create a separate record. So on the record where repman yn is equal to no, so we are assigning the text rp all to rp test cd. At the same time, we were asked to use the value of reproductive system findings in rp test, so we are assigning that. On this record of RP all, as this is not collected, so we were asked to populate RP stat as not done. So we are assigning not done to RP stat variable, and we were also asked to populate the value of not collected in RP resend. So we are assigning that to this variable and then outputting the record. So on the record where repman yn is equal to no, so we would create a row with the values of these variables as indicated here, and then this record would be outputted. So otherwise, if repman yn is equal to yes, so when the assessment is performed, we would have the information for childbearing potential and menopause status collected. So if it is yes, so we would get one record for childbearing potential and one record for menopause status. So we are doing that here. So first we are checking if the repman yn is equal to yes or not. If that is the case, so we are first trying to create the row for childbearing potential. So we are using the value child pot in rptestd variable, and then we are assigning the value of childbearing potential to rptest variable. So there are some leading spaces here which should not have been there. So I'll try to correct it post making this video. So and then we are checking if the value present in childbearing potential is null or not. So if it is the case, so we are indicating it as not done. Otherwise, we are uh, creating the value. We are assigning the value in child pod to RPORRES variable. So we are additionally checking if the result is missing or not. If the result is missing, so we are saying it as that information is not collected or that test is not done. So if missing of child pot, so set it to RP stat is equal to not done and reason as not collected. And otherwise, if the result is present, RPORRES is taking a value from the variable child pot, which means on the record where child pot, so on this record, say for example, we will get the value of yes assigned to RPORRES variable. And we have seen in the specification that both the questions of childbearing potential and menopause status do not have any units associated with the response. So we are setting the unit to null. And for STRESC and STRESU, we were asked to present it as copies of original result and original result units. So we are assigning those statements here. And then finally outputting the record. And then we are moving on to the creation of the record where menopause for menopause status. So what we need to ensure is when we are trying to create more than one record from within a single record on the source, so we would have to ensure that all the newly created variables are set to null so that no value from the previously assigned values get carried forward onto the new variables. So we are setting, after outputting the record, we are setting all the newly created variables to null here using call missing function. And then we are creating the row for menopause status. So we are assigning the text of menostat for rptestd, and we were asked to use the value of menopause status in rptest variable. So we are assigning it here. And then we are checking if menopause status has a value or not. If we do not have a value here, we are setting the value of RP status is equal to not done. And then we are also indicating that the information is not collected. Otherwise, when the result is present, so we are assigning the value from menopause status to RPORRES variable and then setting the units to null and assigning the value from original result to standard result character format and then original result unit to standard result unit as per the specification, and then outputting the record. So here in this case, when repman yn is equal to no, we would have got one record with the rptestd is equal to RP all, and the record where repman yn is equal to yes. So we are creating two records of this. So one is for childbearing potential and the second one is for menopause status. So we would get two records out of this and two records out of this. So it will be 4 and then one record here. So if everything goes fine in our RP01, so based on this data, we are expecting 5 records in our RP01. So let us see if that is the case. Yes, so we have 5 records here. So let us examine this one. So here, this is the RPOL record. On this record, repman yn was no. So we were creating this RPOL record. So on the second record, so we are creating this first record for childbearing potential using the information from child pot variable, and then the second record with rp test id is equal to menostat from the to store the information from menostat variable. And then we are presenting the results here, and then we have the last two records created from the third record present in our repmen dataset. So let us now move on to the next step. So we are trying to create our study day. So for that, what we need is our RFSTDTC from DM dataset. So we are sorting our RP01 dataset based on the values present in uSubjID, and similarly we are sorting our DM dataset based on the values present in uSubjID, and then merging these two datasets. So, and we are bringing only uSubjID and RFSTDTC from demob dataset when merging these two based on the values present in uSubjID. And then, so in order to calculate the difference between our dates, so we need to convert them into numeric format. So we are creating variables called RFSTDT, RPDT to store the numeric variants of RFSTDTC and RPDTC. So as we need to calculate the difference between RPDT and RFSTDT, so we cannot calculate the difference if they are in character format. So we need to create numeric variants of it. So we are creating numeric variants of both RFSTDT and RPDT. So let us quickly see how that is being achieved. So we are checking if RFSTDTC is not null, and then we are converting RFSTDTC to numeric format using input function. So we know that dates in ISO 8601 notation, when they only have date component, they have the dates in this SAS format, in format of YY MMDD 10 dot. So 4-digit year followed by 2-digit month followed by 2-digit day with a hyphen in between, and then the overall width would be 10. So we would convert that into numeric value. And similarly, we are processing it for RPDTC. We are checking if RPDTC is not null, and then in that case we are converting it into numeric format. And then we are checking if both RFSTDT and RPDT has a value. So we are checking that using nmis function. So what does nmis function do? So if we pass a list of variables to nmis function, it would return us the number of variables that has a missing value on any particular row. So if both RFSTDT and RPDT are not null, so as the number of variables that we have passed is 2, so both of them have a value, it would return a value of 0 because none of the value variables passed to it has any missing value. So on those rows when both of them are present, so we are calculating our RPDY. So we are calculating the difference between RPDT and RFSTDT, and then so we are employing this logic of checking whether RPDT is greater than RFSTDT. So if this is true, the resulting value that would be returned is 1. Otherwise, the value returned would be 0. So as per the definition, this difference of RPDT and RFSTDT was common, and if RPDT is greater than RFSTDT, greater than or is equal to RFSTDT, so we were asked to add the value of 1. So instead of manually adding it, so we are making use of this expression. So by automatically checking whether if it is true, so it would return the value of 1, otherwise it would return the value of 0. So this would be equivalent to RPDT minus RFSTDT plus 1 or plus 0 based on whether this date is greater than RFSTDT or not. And then we are applying some formats to the newly created date variables. So let us take a look at our RP02 dataset. So we should have our RFSTDTC appearing at the end, and then the numeric variants of RFSTDTC and RPDTC, so which is our RFSTDT and RPDT, and then we have our RPDY calculated. So here if we see, we have RPDY coming as 1, and then we have two records with a value of -5. So now we completed our study derivation. So in this example we are seeing, so the visit definition or the derivation is simple, and we are being asked to directly present the values from source variables of folder seek and folder name. So we are using folder seek variable to create visit num, and then converting the values in folder name to uppercase and assigning it to the visit variable. So this completes our visit variable definition. So let us take a look at our RP03 dataset and see if we have the values present. So we have visit and visit num populated. So now comes our creation of epoch variable. So for this, so we were asked to compare our RPDTC with the start and end dates of each of the elements of each subject. So we will try to create our processing of SC to get the start and end date of each epoch of each subject onto a single row. So we are using our SC dataset and creating a new dataset called SC02, and then we are creating a temporary variable called short by extracting the first character from the epoch variable. So let us take a look at our SC02. I think I have not kept SC02 here, but let us quickly see what the expected value could be. So we are extracting the first character from epoch value. So S, T and F would be the possible values in short variable. S from screening, T from treatment and F from follow-up. So let us see what is being done next. So, and then we are creating a sorting SC02 based on use subj ID and transposing the element start date of each epoch, and we are indicating that the newly created variable name should have the values coming from short variable, and then the newly created variable should have a prefix of s added. So again, I have not kept these intermediate data sets epoch start, but kept this next data set here. So we'll see how this would be processed. And then, so this would create one record per each subject with a column for the start date of each of the epoch. So we are doing similar processing for our end date of each epoch. So we'll now see what is being done next. So we are bringing the start date of each epoch and end date of each epoch of each subject into a single data set. So let us see how this looks like. So here SS stands for start of screening, start of treatment, start of follow-up, end of screening, end of treatment, end of follow-up. So we have transposed our SE02 the first time and created this dataset called epoch start. So in this we have used SESTDTC as the transposed value. So in this step, so these variables SS, ST and SF are coming from epoch start dataset. So we have one record per subject with the variables of containing the start date of each of the element. And then we have done similar processing but with the end date. On this dataset we are naming the variable names using a prefix of E. So ES is nothing but end of screening, ET is nothing but end of treatment, and then EF is nothing but end of follow-up. So we have the start and end date of each of the elements available on a single row. Now we need to bring these date values into our RP dataset so that we can compare our RPDTC to the start and end dates of each of the elements and assign the epoch accordingly. So we are doing that here in the next step. So we are sorting our RP03 dataset and creating a dataset called RP05 and based on the values present in new subj ID. And then merging our epoch dates to RP05 and creating a dataset called RP06 at subject level and keeping a record for all the subjects who are present in RP05. So let us take a quick look at our RP06 dataset, which should have all the start and end dates of each of the elements or epochs of each subjects across all rows of that subject. So we have the dates available now. So in the next step, we would be comparing our RPDTC with the start and end dates of each of the elements and assign our epoch variable. So let's see how that is being done here. So we are creating a temporary variable named YMD and assigning the value from RPDTC to it. So we are checking if our YMD is nothing but our RPDTC here. So here we are checking if our RPDTC is in between. No, so if our screening start less than or is equal to RPDTC less than start of treatment. So R if the subject did not enter into treatment. So the subject will have the treatment start date as null. So in that case, if so let me go back a little and then try to explain this condition again. So we are checking if our RPDTC is in between screening start and screening end, but we are not excluding the treatment start here. So because we were asked to use the condition if the RPDTC is falling on the boundary of start of treatment and end of screening, so we were asked to populate it as the value of treatment. So we are only considering till less than start of treatment here. So otherwise, if subject did not enter into treatment, so we are checking if the date is falling in between start of screening and end of screening, both inclusive. So in those cases, so we are assigning the value of screening to the epoch variable. Basically, we are checking if the record is falling in between the start and end of screening or just before treatment start. So if that is the case, so we are assigning the text of screening to the epoch variable. And then we are checking if else if. So if this condition is not met, so we are checking if our RPDTC is in between start of treatment and end of treatment. If that is the case, so we are assigning the value of treatment. Else if end of treatment is less than RPDTC less than or is equal to end of follow-up, we are assigning the value of follow-up to the epoch variable. So let us try to take a look at our RP01 and then see the epoch variable and try to understand why the epoch value on a particular record is coming that way. So here if we see the epoch variable on first record, so is coming as treatment. So let us see the RPDT here. So it is 15th Jan 2010. So let us see what is the start and end dates of our treatment. So start of treatment is 15th Jan, end of treatment is 25th Jan. So as per the definition, so if something is falling in between the start of and end of treatment, so we were asked to assign the value of treatment. So this is coming correctly here. And then on the second record also, so the RPDT is 15th Jan. So this is on the date of treatment start and in between the end of treatment start date. So it will be treatment here. So let us see this fourth record, so which has a value of screening, and then try to understand why this is coming as screening. So here on this record RPDT is 29th Jan 2010. So let us see the start and end dates of screening for this subject. So start of screening is 27th Jan 2010 and end of screening is 3rd Feb 2010. So which is falling in between the start and end of screening. So 29 Jan is in between 27 Jan and 3rd Feb. So we are getting the value of screening. So and the same case for the next record as well. So now next move on to the creation of baseline flag. So as per the definition, we were asked to populate it on the record with latest record with non-missing result on or prior to treatment start date. So we are filtering those records which are on or prior to treatment start date by using the condition of RP DTC less than or is equal to RFST DTC and then filtering only those records with non-missing result. And we are storing the resulting records in base 01 dataset. So there can be one or more records per subject before on or before treatment started. So, but we are supposed to use the latest one. So in this sorting, we are ensuring that the latest record would be appearing as the last record within each RPTSD of a subject. So in the next step, so what we are doing here is subsetting that last record within each subject and RP test CD. So in the prior sorting, we have ensured that the last record would be the latest record. So we are filtering the latest record. And then this gives us the latest the date on which a particular RP test CD of a subject is becoming baseline. So we would you have to use the information of that subject RP test CD and RP DTC and then populate the baseline flag in the parent dataset. So we are sorting our parent dataset RP07 based on U sub JD, RP test CD and RP DTC. And then we are making use of the date of each test CD of a subject that is becoming baseline here and to populate our RPBLFL. So we are merging RP07 with base 02 which has the date time of a particular test of a particular subject which is becoming baseline. So if there is a match to the date time of a test CD of a subject in the base 02 on that record, so we are populating our baseline flag as Y and the resulting dataset is called as RP08. So let us now open our RP08 and then see the record which is becoming baseline flag. So here we have two different SCDs on day one. So these are the latest records on or before day one. So these two records are of same subject and the last two records are of different subject. So here, as these are the latest records within that subject and SCD, so these are becoming baseline flag. And similar is the case for the next subject. So why do we not have baseline flag on this record? So let us see that is the case. So here if we see, this is a not done record. So RP all. So this would not qualify because the result would be null on that record and also the date would not be present on that record. So here the baseline flag is not populated on that record for that reason. And then finally we are creating our RPSeq variable. So I think in the specification a different set of variables is used, but I am going here with USUBJD, RPTestCD and RPDTC. So to align with the specification, we can change the derivation here accordingly. I'll try to do it post recording this video. I will try to either update the specification or update the program. So we are sorting the records based on USUBJD, RPTestCD and RPDTC. And then on the first record of each USUBJD, so we are setting the value of 1 to RPSeq variable. On all the other records, so we are incrementing it by 1. And then finally, we are keeping only the variables which are specified in the specification and then ordering them in a logical sequence using this retain statement. So let us take a look at our final data set RP to see how it looks like. So we have the 5 records, 1 record for each test CD possible as per the collection, and then we have all the SDTM variables. RPStat, RPReasonD, RPBLFL, VisitNum, Visit, Epoch, RPDTC and RPDY. So this is how you can create your RP domain. Thank you for watching and keep learning.